Okay, this week we are going to be doing congruent chords and arcs. Okay, this topic's actually super easy, and they're gonna make you do some stuff that's a little bit harder with it. You're gonna have to use some background knowledge with it, but the topic is really super easy. So you guys should be fine this week. I did not do a quiz this week, so your grade this week is just going to be doing your homework and sending me a picture of it. So you don't have to print this out or anything. If you want to print the homework out, that's fine, but if you don't have a printer, that's totally fine too. Just label it numbers 1 through 16 and just show your work on there, and then take a picture of it and email it to me. Okay, just a reminder before we start, because we're going to use the word congruent a lot, and I want to make sure that you remember what congruent means. So congruent just means equal in measure. So they're just equal in measure. So two chords, remember, for example, A, B, and C, D, those are chords. Two chords are congruent if and only if their corresponding arcs are congruent. So for example, AB equals CD if and only if the measure of arc AB is equal to the measure of arc CD. So let's look at this and see kind of what that means. So AB is this chord and CD is this chord. So this is saying that these are only equal if arc AB, so that's this arc, is congruent to this arc CD. So those two green pieces are congruent and those two yellow pieces are congruent. They're only congruent if both parts are congruent. So the other piece that this has to have, and you kind of probably could already guess this, is that for those two yellow chords to be congruent to each other, they have to be the same distance away from the center. If they were a different distance, so say CD was here, that would make that chord longer. So that's our part B, is they are equidistant from the center. So AB, whoops, equals CD, and that is because these two pieces, EF and EG, are equal to each other. So that's what we're going to say is EF equals EG. So you're kind of seeing that they all have these parts that are equal to each other, and that's what you're going to be using on today's stuff. So let's finish filling these in, and then we're going to use that. So if a diameter or radius is perpendicular to a chord, then it bisects. So remember, bisect just means splits in the middle. So it bisects the chord and its arc. So the way we're going to say this is that EH is perpendicular, remember that's what that symbol means, to AB if if and only if AF equals FB. So that means these two little pieces are equal and that EF or EH and AB are perpendicular to each other. And the other piece to this is we have that those two are equal to each other, so also their chords, so the measure of AH, arc AH, is equal to the measure of arc HB. So these are equal to each other as well, if and only if that is a perpendicular bisector. So basically, just all of those parts, I guess you could say these are equal to each other as well. These are equal. Those other little black pieces to G, E, and FE would also be equal, but I'm not going to fill that in. Basically, this lesson is just having you use all of those equal parts to solve for a variable. So it's pretty easy. Okay, so let's go ahead and start on this first one. It says to just find x. So we know that those two chords are equal. So that means that these two arcs must also be equal. That's what we just did. So we're just going to say 7x plus 24 equals 115. If we subtract 24, then we have 7x equals 91. And if we divide by 7, then we have that x equals 13. And that is our answer. So it's pretty easy. It's just knowing what those theorems are and knowing that those pieces are equal. So I'm going to have you guys try problem 2. So go ahead and pause, and when you press play, you'll see the answer. Make sure you're trying it on your own first, though. Okay, so you should have seen that those two arcs are equal, so their two chords must be equal as well, and just have set them equal to each other, and then solved for x. Okay, this one has one extra step that we have to do. This is why it's really important that you guys read directions, because this says to find xy. Xy is this line segment. So we are going to solve for x again, but we need x to find the length of xy. So let's go ahead and set those equal to each other first, because their arcs are equal, so their chords have to be equal. So we have 9x minus 34 equals 4x plus 1. Let's go ahead and subtract 4x from both sides. And we get 5x, oops, minus 34 equals 1. Let's add 34 to both sides. And divide by 5. And we get x equals 7. Now we want to find the length of that segment, so we're going to have 4 times 7 plus 1, and we get that the length is 29. So that is our answer. Okay, now I want you guys to try number 4. It's super easy, as it's super similar to problem 3. So go ahead and press pause, try number 4, and when you click play, you'll see my answer. Okay, the biggest thing that I want to point out here is that this is degrees. Remember that arc measures are in degrees, so you have to have that degrees there. And you should have gotten 71, so go ahead and check your answer. Okay, this one's a little trickier. We have to think about what we know about circles. So we're finding x, and we know that a circle is 360 degrees. So I'm going to go ahead and take out that 76 degrees. and we are left with 284 degrees. So we know that this arc plus this arc is going to be 284 degrees. We also know that those two arcs are equal, so two of these are going to be 284 degrees. So the way we say that is two of those is 284 degrees. So we're going to have 2 times the quantity, 6x minus 20, equals 284. And we're going to go ahead and just solve for x. Divide by 2 first. You should get 142. So 6x minus 20 equals 142. Add 20. So 6x equals 162. And if we divide by 6, we should get that x equals 27. And that's just x, so you don't need degrees. Okay, now it says use MP and PN to find the measure of MP. So MP is this little piece, and PN is this little piece. Remember that if those are perpendicular, which that's what those little squares mean, that means that those are also equal in length. So that's what we are going to do, is just set those equal to each other, and then we're just going to have to plug in x for x in MP. So we're going to have 5x minus 34 equals 2x minus 4. Let's go ahead and subtract 2x from both sides. So we get 3x minus 34 equals negative 4. Let's go ahead and add 34 to both sides. So 3x equals 30. Divide by 3. And we get that x equals 10. Now we just need to plug that in up here. So we're going to have 5 times 10 minus 34. And we should get 16. So this answer, so MP equals 16. Woo! That's your answer. Okay, I want you guys to go ahead and try problem 7. 7 is very similar to 6, which we just did, except for you have 2 different pieces now, but they are still equal to each other. So you should be setting those equal to each other, solving for x, and then plugging x in for DE. So go ahead and press pause, and when you press play, you'll see my work. Okay, you should have gotten that DE equals 37, and those are just chords, so it's not a degree measure. It's just the length of 37 because we don't really have units on this. Okay, this next one is a little bit different. Notice that it says to find the measure of MP. MP is this arc right here. So we have the measures of the other 2 arcs. We don't have the measure of that one. However, we know that all 3 of those arcs added together are going to be 360 degrees because it's a circle. So we're going to go ahead and set those equal, solve for x, find the length of one of those. So we'll just say we'll find the length of this one. And we know that both of those 2 are the same. So then we're just going to have 2 of those, and we're going to subtract that from 360 to go ahead and get our last arc. So let's do one step at a time. Let's go ahead and set those 2 arcs equal to each other first. So 9x minus 43 equals 5x plus 33. Let's go ahead and subtract 5x from both sides. And then let's go ahead and add 43 to both sides. going to divide by 4. And we should get x equals 19. So now we need to plug that 19 in to find the measure of this. So let's do 5 times 19 plus 33. And we should get 128 degrees. So I know this is 128, and this is 128 degrees. So let's do 360 minus 128 minus 128, and we should get 104. And that's our answer. This is 104 degrees. Mine is not letting me write degrees on here for some reason, so I think I'm just too far off the edge of the page. There we go. Okay, these next two, we're just going to use the information they gave us to find multiple pieces. So it says in circle Z, RS is 18. So let's find RS. That is 18. And the measure of our TY is 42 degrees. It says to find all the rest of these. So we want to find TB next. Whoops, I actually labeled the wrong thing for RS. It is not arc RS, it is chord RS. Sorry guys. That makes a little more sense. Okay, so now it wants us to find TV. And if we are finding TV, TV is half a chord, and we know that our chord is equal to 18, so half of that would just be 9. TU is a full chord. Well, a full chord is just 18. Let's see, WS is half a chord, and half a chord is 9. This is WS. YU. YU is just half an arc, and we already know that half an arc is 42 degrees, so we're just going to write 42 degrees. Now it says to find RS. So RS is this whole arc. We know that half an arc is 42 degrees, so if we do 2 times 42, we should get 84 degrees. So as you can see, these are actually super easy. It's just a new concept you guys haven't done yet. So you guys should be fine on this week. The last 4 problems I'm going to have you guys do today are going to be a little bit more tricky, but these last 3 right here should not be bad. So let's go ahead and finish them off really quick. So it says in circle I, if BG, so chord BG is 17, and BG is actually half of a chord, but it's 17, and the measure of arc CHA, so this is C, H, and A, so we have that major arc is 256 degrees. It says to find each measure. So BC is what we want first. Well, BC is just a full chord. We know that half a chord is 17, so if we need a full chord, that's just going to be 2 times 17, which is 34. Now we want FB. FB is just half a chord, so it's just 17 again. Now we want the measure of arc AB. So here's AB. Now here's the tricky part. I'm going to give you part of this. So AB is the same length as BC. We know those two are equal. So we're going to take 360 degrees and subtract this major arc from it. and we get 104 degrees. So that would be the length of this whole green piece. However, we only need half of that because we want the length of AB. So we're going to take 104 and divide it by 2 and get 52. So the length of AB over here is 52 degrees. Okay, now BC. BC is the same thing as AB, so it's also 52 degrees. Now we want the measure of EC. Okay, EC, we have a lot of writing on here, so I'm going to erase some stuff. So EC is just half of this arc that we had before. So half of 52 is 26 degrees. Okay, let's go ahead and do 11. So 11 says if QM, that is this piece, is 6x minus 11, and MR is this piece, is 2x plus 9, they want us to find MN, which is this whole piece. So MN is the whole chord, and QM and MR are half a chord. Those are both half a chord, so we can set them equal to each other. Okay, so let's go ahead and set those equal. So we have 6x minus 11 equals 2x plus 9. Let's subtract 2x first. And then let's add 11. And divide by 4. So we get x equals 5. Now we want MN, so this green piece over here. But MR is half of that, so let's go ahead and find MR, and we'll just multiply it by 2. So we'll have 2 times 5 plus 9, and we should get 19. Well, 2 times 19 is 38, so MN equals 38. Okay, this last one, they tried to throw you a little bit of a curveball, but it's not bad. So it says the measure of arc CI, which is that little half arc there, is and measure of arc EF so we have those two. We want to find the measure of CI. However, we can see that EF is 2 times the length of CI. So we would have to multiply CI by 2 to get EF. So we need 2 of CI to get EF. So we're going to set those equal, and then we're just going to have to plug in for x at the end. So let's divide by 2 first. And we get 7x minus 15 equals 6x minus 4. Let's add 4 to both sides. And let's subtract 7x. I'm going to put my work over here on the right. So we get negative 11 equals negative x, or just 11 equals x. Okay, now we just need to plug it in to CI. So we have 7 times 11 minus 15. And we get 62. And remember, it's in degrees. Okay, we are actually going to skip 14 and 16. And then on your homework, don't do 14 and 16 as well, because they're going to use the same concept on the homework. So that's going to tell me if you watch the video or not, is if you do 14 and 16 on the homework also. So please don't do 14 and 16. You guys have to use trig for those ones, and I'm not going to have you guys do that. You know the trig to get there, but I think what you guys have to do for homework is enough as it is. So let's go ahead and do 13 and 15. So 13 says find the length of VW. Now we're going to use half of that to find, we're just going to find the length of ZW and multiply it by 2. And we can see that this is a right triangle. So we're going to use this right triangle and the Pythagorean theorem to go ahead and find the length of ZW, and we're just going to multiply that by 2 to find VW. So we are going to just label this x, and we're going to say that x squared plus 5 squared equals 13 squared. That's just the Pythagorean theorem. So x squared plus 25 equals 169. If we subtract 25 from both sides, we get x squared equals 144. Take the square root of both of those and we get x equals 12. Now, we know that's just the length of ZW, this x part right here. So if we multiply that by 2, we get that VW is 24. Pretty easy. You just have to think about what you know in math already and use it to your advantage, which is kind of what your math classes are going to be like from here on out. They're going to use the math that you already know and have you apply it in other ways. Okay, the next one, 15, is very similar. So we have HK, which is this chord, is 30, and PM, which is this little piece, is 8. And we want to find pH. Okay, so just a hint here again, we have a right triangle. This is also 90 degrees if the other side is 90 degrees. And we know that this piece is 30, so half of this one would be 15. So we have 8, we have 15, and we need this side length, so we're going to use Pythagorean theorem again, and this is going to be x. So we're going to say that 8 squared plus 15 squared equals x squared. Remember, it's always set equal to the hypotenuse, and the hypotenuse is what we're trying to find in this case. In the last one, we were given the hypotenuse. The hypotenuse is the longest leg. Okay, so now we have 64 plus 225 equals x squared. And let's go ahead and add those together. So we get 289 equals x squared. And square root both sides to get 17 equals x. So pH equals 17. And that is your answer. So go ahead and do your homework. Remember that your grade for this week, you don't have an online quiz. Your grade for this week is just doing the homework and taking a picture of your answers with your work. That's the key. You have to have your work with it. So all of this work that I've shown, you should have that on yours as well. When we're doing stuff in class, sometimes I'll let you guys do it without showing your work, but I'm obviously not there to check up on you guys right now. So you guys have to show more work than you've ever had to show before, just because we're not in class. So just make sure you're showing all of your work. If you're doing it in your head, just go ahead and write it down. Just because we're doing the online school stuff, then I can check your stuff for you. So go ahead and do your homework, take a picture of your answers with your work, and email it to me, and that is your grade for the week.